So what we want to do next is to be able to go to our circle or create a circle. You can say Command Enter to go to the definition, or Control B on Windows, as you can see at the bottom here. And so what we want to do is when the circle is clicked, we don't want it just to show what we see here. We want to be able to do something. Ideally, we want to be able to increment this value here. So let's test things out first. We want to be able to increment a value, which means we need to create that value or that variable. So let's go still inside of our function here, outside of our card. And I'm going to initialize a val. Let's say money counter and set that to 0. That's the first initial value, okay? And so here, what I can do, I can hopefully say something like this. Money counter is equal to money counter plus 1. So each time that we click on this money counter, we are going to increase it. But of course, I'm going to have an issue because, of course, I said val, but this should be var, so that we're able to mutate this. So this is immutable. So if you have val, that's going to be immutable, meaning we can't change it, but var will change it. Makes sense because we need something that changes. And we still have an issue here, or rather a warning. So let's hover over and see what's going to happen. It says here replace with operator assignment. So yes, let's do that. It's smarter this way. Either way would have worked, but this is succinct and the way we should always do it. Okay, let's run this. Actually, before we do that, let's go ahead and say log D again, because we want to see in our console this value. So I'm going to go ahead and say my counter to see if it actually changes anything. Money counter, that it is. Okay, and just going to say counter. All right, let's see. Let's go ahead and run. Let's go ahead and also open our console there, and I'm going to say I'm going to look for counter, right? So we can see the results just for counter. Okay, let's go ahead and see. All right, so I keep clicking and I don't see anything. Maybe I missed something. Let's see. Is that true? Okay, let's see. Counter. Okay, that's nice. Circle 1. And it works fine. Okay, because we can see as we tap the values being incremented. That's fine. Now let's see something else here, because the idea really it's not to log these values. The idea is to hopefully see the changes somewhere in our UI. Let's change, for instance, this tab instead of saying tab, I'm going to attach another variable here. In this case, it's money counter variable. Let's see what's going to happen now. So I'm going to go ahead and leave that as it is. I'm going to run this. So the idea is that as I tap, I should see money counter also going up, just like we saw here, right? Let's wait for a second. Okay, let's try again. Click. We notice that the counter works fine. 2, 3, and so forth. However, when it comes to changing our text here, you should say tap, also incrementing, right? First 1, and so forth. This tap money is the same variable that we are showing in our log here. Yet in our log, it's going up, but the moment we attach to a composable, a UI, a piece of UI here, UI widget, then we don't see that change. What is happening here? Well, this is an important concept that we really need to understand in Compose, which is in order for us to see changes in our text here, or in this case, in any other composable function, as you see here, this is not going to do it. The reason being is because whenever we want to change something inside of a composable function, in this case, a text, right? We need to redraw that composable, which means this text here has to be redrawn with the new value. And if you remember correctly what we talked about between the difference between the imperative approach in Android development versus the declarative approach. In the declarative approach, we are passing data through the composable functions, and then the composable function reacts to that data. That's the idea. So how do we make this to react to that data, which in this case mean to rerun itself, to redraw itself? By the way, this redrawing itself, it's called recomposition in Compose, and we'll talk about that in a second. For that to happen, there's a special variables that we need to pass here, or we need to create for this to happen. This special variable will create what's called an internal state, because we need that state so that we can control that something has changed. That way, this composable text here will know, oh, my data, money has changed. That means I have to redraw myself, recompose myself to show that new change. Interesting. That means then, in our case here, what I will need to do, I'm going to say var money counter. I'm going to use delegation here. I'm going to say by to delegate this responsibility to some other class we don't even have to know about. I'm going to say mutable state of like that. And this mutable state of, I'm going to pass a value of 0 in the beginning. So what are we doing now? We are saying this my counter is not going to be just an integer. It's going to be something that is wrapped into a state which is needed for us to be able to, obviously here, to recompose our text so it gets the correct value as the value is changed. Obviously, so we're going to have some issues here because we need to import a few things. So just hover over like this. You can go ahead and import, or you can just say Alt or Option Enter. It's going to start importing everything that we need. We imported that, but we need to keep importing until that it's not read anymore. Now we have another problem here. If you hover over, it's going to say, okay, creating a state object during recomposition without using remember. So that's another concept here that needs to be addressed. The idea is that when state changes, obviously the UI must also change. That means then we need a way in which this function here, composable, will always remember the state. So that's what's happening here. So we need to actually say something like this. So I'm going to say here by, and then start writing here remember like this, hit enter. And remember is a lambda. So now we're going to take this mutable state of, just put that inside there. So what we're saying now is that, yes, we are going to create a mutable state of, and we pass the value here. The init value is 0, which will be implied to say this is indeed an integer. And then we're going to have to remember that state. And all that is going to be, and we are going to put all that value inside of my counter. So now this no longer is just an integer. If you hover over, it says my counter is an int. However, we wrapped it inside of remember as well as a mutable state, which is really important. So now if you use my counter, things are going to work. So now let's see if this works. I'm going to go ahead and run this. Okay, let's see if this is going to work. Remember, I still have counter here on debug and it's open. If I click, and you can see, make this a little bit bigger. You can see now tap is 1, 2, and is working as intended. So what's happening here, because we have that state attached to my counter and it's being remembered, what's happening now, the text will know that, okay, this is being changed the moment that we click. Since it's being changed, the value is changing, and I will remember that because it's because we have a state and it's going to be remembered. What happens now, this is being recomposed, meaning it's being redrawn again each time that this value is changing. That's why we're able to see what's happening here, 10 and so forth. And just now you've learned one of the most important concepts in Compose, which means we need to have a state for us to be able to see changes, to update a user interface. In this case, this text or any other composable function out there. So you see the difference here is that we have data and we pass that data through our widget, in this case our compose function, and then that's when the compose function will then come to life or will update itself, because it will know now it's time for me to update myself because I have new data. And that's why this is working now. Very good. So now we're going to take a little break and go and understand a few other concepts that surround this one concept we've learned, right? We need to understand a little bit more how this recompose, because I've talked about recomposition and so forth. What is it and how all of that works? And then we're going to compare again the imperative approach versus the declarative approach, which is what we're using here.